AI Podcast. Welcome, everyone. I'm David, your commentator. Today, we're looking at a Findings of ACL 2025 paper on a system called MAT-MCD. Here's the quick headline first. The authors show that letting language model agents bring in outside text, like web pages and system logs, can guide classical causal discovery and make the learned graphs cleaner and more useful. In their tests, error rates drop markedly, and root cause ranking in microservices improves a lot, with gains reported up to roughly 2/3 on one error measure and about 80% on a ranking metric.
I'm Elena. Thanks, David. That sounds promising. Who led the study and where are they based?
It's led by ChengAo Shen at the University of Houston, with Zhengzhang Chen at NEC Laboratories America as a key co-author. The team also includes collaborators from Florida International University and North Carolina State University.
All right, before we get into the details, what's the problem set up here? Why do we need this?
Classical statistical causal discovery learns a directed graph from observational data. It's rigorous, but it treats variables as if they were nameless columns. In practice, variable names and surrounding context often carry meaning. Horsepower and weight in a car dataset aren't just numbers. In microservices, a pod named ratings or reviews hints at relationships. Most earlier work with language models didn't fully tap those cues, and almost none seriously explored bringing in extra modalities like web text and operational logs to help orient edges and filter spurious ones.
Right, so we've had good math on the data side, but not much use of the semantics that people take for granted. What exactly do the authors propose?
They wrap a standard causal discovery algorithm with two cooperating agents. First, they run a baseline method to get an initial graph. Then a data augmentation agent looks at the dataset name and variable names and decides whether to call tools. For general context, it can query the web. For AI ops, it can look up templated logs. It summarizes what it finds into short, digestible notes. Next, a causal constraint agent reviews each candidate edge using those notes and decides whether the edge likely exists and in which direction. Those decisions become constraints, and the base algorithm refines the graph under those guardrails.
So the language model acts like a careful domain consultant. It doesn't replace the statistics. It just nudges the solver away from unlikely edges and toward plausible directions.
Exactly. The authors also mention guarding against information leakage during retrieval. For example, you wouldn't want the system to accidentally pull a ground truth graph from the web and then claim a win. They screen for that.
Good to hear. How did they test MAT-MCD?
They evaluated 5 well-known benchmarks, including AutoMPG, DWD Climate, SAX Protein, Asia, and Child. Those cover continuous and discrete variables. Then they ran 2 case studies in microservice environments for AI ops, where they had metrics and logs along with known incident root causes. For baselines, they compared against classical algorithms and several language model-assisted methods. The main focus was whether the agent system could refine the graphs that a standard method produces.
And did the approach help in practice?
Yes. On the benchmarks, the refined graphs tended to have fewer added, missed, and reversed edges than the baselines. On the microservice datasets, the gains were especially clear because logs provided extra context. Using the learned graphs to rank likely root causes, the best baseline sat around the low 30s on a top 10 metric, while the proposed method reached the mid-50s and roughly doubled a reciprocal rank measure. The paper also summarizes overall improvements with phrases like up to 2/3 reduction in a normalized Hamming error and around 80% improvement in that ranking metric over the strongest baselines.
That lines up with what on-call engineers want. If the true culprit shows up near the top instead of down the list, you save a lot of time. Any caveats you'd flag?
A few first. The constraint checks are done per edge, which grows quickly as the number of variables rises. The authors suggest moving towards subgraph level prompting to scale better. Second, the approach benefits when variable names and brief descriptions are meaningful. If names are opaque or redacted, the gains may shrink. Third, some tool choices and models in this space can be hard to replicate exactly across environments, so careful reporting and open alternatives will matter. And for the AI ops studies, evaluation is indirect because we measure the usefulness of the graph for ranking root causes rather than verifying every edge of a ground truth graph.
Makes sense. Given all that, what's your take on future directions?
3 directions stand out. 1, make the prompting more scalable by reasoning over subgraphs instead of every pair of variables. 2, expand modalities beyond web text and logs to include structured knowledge bases or code when that's the natural context. 3, tighten the retrieval pipeline with leak detection and require concise, source-backed justifications for each constraint. The authors have also released code on GitHub, which should help others build on this work.
Great. Let's close with a quick recap.
Sure. MAT-MCD shows that small, well-chosen bits of external text can give language model agents enough context to guide classical causal discovery. The result is cleaner graphs and better guidance for downstream tasks like root cause analysis. It doesn't replace statistical methods. It augments them with common sense and domain cues gathered responsibly.
Appreciate it, David. That's today's AI podcast. Thanks for listening.